Hello, we're going to do Unit 1, Lesson number 3, Composition of Functions. So a composition of functions just means that you have two functions that you are evaluating for the same question. In this first example, they are illustrating this by making us solve an equation or solve for a value first, and then we need to use that value that we found in part A to complete part B. So it's a composition because I need the answer I found in A to solve part B. A circular garden with a radius of 15 feet is to be covered with topsoil at a cost of $1.25 per square foot of garden space. Determine the area of this garden to the nearest square foot. Well, if you remember, the formula for the area of a circle is pi r squared, and in this case the area is going to be pi times the radius of 15 squared, which has a value of 707 feet squared. Using your answer from part A, calculate the cost of covering the garden with topsoil. So I need that value of 707. I'm going to multiply it by the cost per foot, and I get a value of $883.75. Okay, so now it says we have two functions. We have this f function and we have a g function. The f function is x squared minus 5. The g function is 2x plus 3. So in letter A, it looks kind of weird because it's asking us to evaluate f of g of 1. So whenever you do these, you always evaluate from the inside first. So first we're going to evaluate this part. We're going to evaluate g of 1. Right? So if you remember, this is an x value. It's saying replace x with 1. So it's going to be 2 times 1 plus 3, which 2 times 1 is 2, plus 3 is 5. Now they're saying to you, take that value of 5 and evaluate it in the f function. So I'm going to evaluate f of 5. So that would be 5 squared minus 5. 5 squared has a value of 25 minus 5. My answer in this case would be 20. Now in letter B, it says g of f of x. So we evaluate the inside first. So now I have to evaluate f of 2. So that would be 2 squared minus 5, which has a value of negative 1. Then it says take that value and evaluate it in the g function. So 2 times negative 1 plus 3. That has a value of 1. And letter C. You are taking the g of 0. So I'm evaluating g of 0, and then I'm taking that value that I get after I evaluate that, and then back substituting it into the g function. So g of 0 has a value of 2 times 0 plus 3, which we know is 3. And now you're going to go back and substitute in 3 in the g function. So 2 times 3 plus 3, 6 plus 3 is 9. Okay. Now these questions down here, they have this little circle thing in the middle, right? So don't get confused. All they are doing is they are rewriting what we just did in a different format. So this would be written as this, right? This guy would be rewritten as this, and he would be written as this. Okay, so if it's helpful and you like the way it looks, or you find it easier to compute when it is written the way that I just rewrote them, then go ahead and do that. So now this is saying evaluate the g function at negative 2 and then substitute that value into the f function. 2 times negative 2 plus 3 is negative 1. Then I evaluate, oh, I'm going to switch my color here. Then I'm evaluating f of negative 1. Be careful when you put this in your calculator. Make sure you use those parenthesis keys. Otherwise, your calculator won't understand what you're trying to do. Okay. I'm going to do these ones rather quickly. You can pause the video if you have to. All right, so that was the composition of function. You take one function, evaluate it as at a specific value, then take that value and you evaluate the other function or whatever else they want you to do with that value. Okay, moving on to the back. The graphs below are the functions y equals f of x, which is linear, and y equals g of x, which is quadratic. Evaluate each of the following based on these two graphs. So it's the same concept except for we're going to use the values of the graph. So this one is saying evaluate g of f of 2. Well, first I need to evaluate f of 2. So I do that by counting over to 2, right, on the x-axis, and this one has a value of 3. So now I evaluate g of 3. Come over to this one, count 1, 2, 3, and this is 1, 2, 3. Letter B saying evaluate f of g of negative 1. So this time I'm going to start on the g function. G of negative 1, well, let's see, that would be right here. So let's say 1, 2, 3, 4. That would have a value of negative 5. And now I'm going to evaluate f of negative 5. So let's see, 1, 2, 3, 4. Here would be negative 5. And if you look, this is at negative a half. G of 1, using my g function, come over to here at 1. Let's see, 1, 2, 3 has a value of 3. And I'm going to evaluate g again at 3, which is 1, 2, 3. Lots of 3's in that one. Now the bottom ones, so now again, these are written in that other form. I'm going to go ahead and rewrite them in the form that I feel more comfortable with. So this means I need to evaluate f at negative 2, which would be right here. So that has a value of 1. So now I evaluate g at 1, which is 3. So this would be f of g of 0. So that means g of 0 has a value of 0. And then f of 0 has a value of, here's when x is 0, has a value of 2. Okay, so this means I'm evaluating f at 0, which is 2, and then I evaluate the f function again at 2, which is 3. Okay, so it's basically, if you want to look at it like the inside part here, this is an x value, and I'm setting it equal to the corresponding y value. Okay, so now we're going to get a little bit trickier. Now I have two different functions again. I have an f function and a g function. The f function is 3x minus 2. The g function is 5x plus 4. And they want us to do a composition of functions on there. So again, we're going to do the same process, just a little bit more arithmetic involved. So the g function, right, I start with the inside, has a value of 5x plus 4. So I'm going to write f of 5x plus 4. Because if you remember, I can't do anything with 5x plus 4 because they're not like terms, so I just leave it like that. Now, I'm going to look at my f function, and wherever I see an x, right, I'm going to replace x with 5x plus 4. So I have 3x. Instead of x, I'm replacing it with 5x plus 4 minus 2. So now I go ahead and I can evaluate this. 3, I'm going to distribute for a final answer of, combine your like terms, 15x plus 10. Letter B. So now they want us to do it the other way. We're going to take the f function and substitute the f function into the g function. So first I'm going to rewrite it. F of x has a value of 3x minus 2. Remember, this is just f of x. So now in the g function, wherever I see an x, I'm going to replace it with 3x minus 2. So the g function says 5x. Instead of x, I'm replacing it with 3x minus 2 plus 4. That's 15x minus 10 plus 4. Combine your like terms. Okay. And the last one. If f of x equals x squared, g of x equals x minus 5, then f of g of x equals. Same process. G of x has a value of x minus 5. So really, I'm evaluating the f function when x has a value of x minus 5. The f function says take your x value and square it. Well, in this case, my x value is x minus 5, and I'm going to square it. Okay, so this really means x minus 5 times x minus 5. And we're going to do what we like to call the Justine method. X squared, two numbers, -5, -5, add to -10. -5 times -5, multiply them, right? Add to the middle, multiply to the ends. So the final answer here for this one is choice 4. All right, guys, thanks for tuning in to Compositions of Functions. And remember, it's just as simple as taking the value from one function when you evaluate it and then substituting that value into the other function that they ask you to evaluate.